Alright. Hello everyone and welcome back to the channel. My name is what? My name is who? Oh, let me sign in, sorry. Okay. My name is Harley from the Fran Play and welcome back to another lecture video. Hopefully this is going to be looking a lot better. I upped the quality, so let's hope, Bubba. Let's hope. But yeah, let's get this going. Let's get our lesson started again. Let's go ahead and open up our command shell. Right, and let's do Chrome. I think that's what you type in. Oh, unless you do that, right? There, you can do commands to like open. Uh-oh. Hopefully I didn't. Oh, okay. Well, I forgot what the. Or maybe it does open it. Cool. All right. What happens if we put stop? Nothing? Cool. Close. Close. End. Kill. Nothing? Okay, well, I don't know. Let's just clear all that. I have no idea, but we are going to go to Google and we're going to go back to what we were learning yesterday. Don't mind the TV in the background, please. YouTube, don't destroy my. Oh, I'm losing. Damn. Okay, hold on. Hopefully this isn't too bad. I do have music playing, so that might be the reason. I'm trying to drown out the TV in the background, but I might have turned it a little too loud. Okay. Alright, hopefully this will be a little bit better. What, baby? Okay. Alright, so we're going to go back to the Odin project and go to the Unix shell lecture. Right? Bada 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 bada. Okay, so we learned about being able to move within directories, right? So we can CD, or actually let's see what we got, right? So desktop, so now we can go CD, desktop, shell, boom, right? And then we can see what we have in there, and I believe we opened up the Geyer. Okay, but anyway, we learned how to navigate. Now we're going to be working with files and directories, right? I think that's what we were doing next. Okay, so now we're going to be learning about files and directories. Oh man, my stream quality is going bad. Let me make sure that I don't have all these devices on or something. Okay. It's also middle of the day, so let's actually close that. Let's see if that helps us a little bit. Oh, we're losing a lot of frames right now. Okay. Okay, what we're going to do is we're going to do a quick reboot of the stream. Dang, I thought we were going to be able to go 720, but it looks like it doesn't want to let us right now. Dang. I really wanted to try to get y'all 720p clear footage, but it looks like that is not going to happen. Yeah, what if we close out of that? I'm trying to do anything to help us at least have somewhat. Okay. maybe we can work with this. I don't know. We're losing a lot of frames right now, actually. Damn.
I told you the internet's been sucking.
The internet has been sucking bad. Okay. Working with files and directories. I'm going to try to go through this as fast as possible to try to keep it 720, and then unfortunately I guess the rest of the lectures are going to have to be in 480, which I'm not happy about, but oh well. Alright. So this is called working with files and directories. What was the... I saw something about pipe, right? Didn't you see that? Oh, okay, the pipeline. Gotcha. And this was kind of like how to go back and forth. Okay. Working with files and directories. How can I create a... Alright, cool. How can I create, copy, and delete files and directories? How can I edit files? Objectives. Create a directory hierarchy that matches a given diagram. Create files in that hierarchy using an editor or by copying and renaming existing files. And delete, copy, and move specific files and or directories. Alright, so creating directories. We now know how to explore files and directories, but how do we create them in the first place? In this episode, we will learn about creating and moving files and directories using the exercise data writing directory as an example. Step 1. See where we are and what we already have. So we should still be in shell lesson data directory in the desktop, which is what I got us to. So here we are. Sorry. Yeah. Or we can just do PWD. Alright, there we go. Next we'll move into the exercise data writing directory. So we're going to go CD exercise writing. Okay. And then we're going to run list F. Okay, and it gives us 2 text files. Haiku text and Little Woman text. Since we just created the thesis directory, there's nothing in it yet. ls and -f thesis. Note that makedir. Okay, wait. Since we just created thesis directory. Oh, I went too far, didn't I? Oops. Let's create a new directory called thesis using the command makedir or make directory thesis, which has no output. As you might guess from its name, makedir means make directory. Since thesis is a relative path, i.e. does not have a leading slash like / whatever thesis, the new directory is created in the current working directory. So now we're going to be in here and we're going to run makedir or make directory and call it thesis. Boom. So now when we run lsf, now we have our 2 text files and a new folder. Alright. And then if we want to list what's inside thesis, there's nothing in it. Right? So note that makedir is not limited to creating single directories at one time. The -p option allows make directory to create a directory that's nested with nested subdirectories in a single operation. Okay, so let's do that. So we're going to be in the same directory, makedir p ... project data space ... / project results. Okay, and then ls fr. So the r option is the list command. To the list command will list all nested subdirectories within a directory. So let's use lsfr to recursively list the new directory hierarchy we just created in the project directory. Okay. Okay, I didn't see anything about moving. We just created a thesis. we made make directory command list also. So it actually, hold on. Okay. Sorry, I didn't do that correctly. Okay, so it told me to list -fr project folder, and there we go. So project has data and results, and then project data, and then project results. Okay, because that's what we created, right? Make dir project data, project results. Okay. And those are the two different folders that we created. Okay, so that makes sense now. I understand that. So when we use that command, make dir -p, and we put // project data, project / results. So in the project folder, we created two folders. We created project data and a data folder and a results folder. So actually, we can go look at that, right? So we were in exercise data, writing, thesis. Oops. Sorry. Yeah, exercise data. No, writing, thesis. Okay, but we're in the same folder here, right? So this is going to show us our project, and it has two folders, data and results. Okay. So that created in our writing folder, those two are the main subdirectory, which was the project, and then within inside of the project folder had another subdirectory, which was data, and another one results. Just so we got a understanding of what's happening. Alright, two ways of doing the same thing. Using the shell to create a directory is no different than using a file explorer. If you open the current directory using the operating system's graphical file explorer, the thesis directory will appear there too. Okay, so it's pretty much, we actually did what they were pinning to us there. No, don't lose sight of the internet, please. Good names for file directories. Complicated names of files and directories can make your life painful when working on the command line. Here we provide a few useful tips for the names of your files and directories. Don't use spaces. Spaces can make a name more meaningful, but since spaces are used to separate arguments on the command line, it is better to avoid them in in names of files and directories. We can either use a dash or an underscore instead of north hyphen or dash specific dash Geyer. So we'll use that instead of using north space specific space Geyer, because the space is using spaces to separate from things is an argument. Okay. To test this out, try typing make dir north and see what directory or directories are made when you check the LSF. Okay, let's try that. Make dir north Pacific Geyer. So what it did was created 3 separate folders. So let's remove north. Okay, I'm sorry. Remove north. So that's how you remove. So remove directory Pacific Remove directory Geyer. Hold on, baby. I'll get you a napkin. Okay, there we go. So now we're back to the same. What happened?
I thought this was a light.
What was it?
Straight up and down.
Oh, she probably dried it out on herself. I wouldn't doubt it. Okay, so don't begin the name with the dash. Command street names with the dash as options. Stick the letters, numbers, period, or full stop. So period means full stop. Dash and underscore. Stick with letters, numbers, period, dash, and underscore. Oh, they call it full stop. Okay. Many other characters have special meanings on the command line. We will learn about some of these during this lesson. You okay, baby? There are special characters that can cause your command to not work as expected and can even result in data loss. If you need to refer to names of files or directories that have spaces or other special characters, you should surround them in quotes. Let's change our working directory to thesis. So using CD, so let's go ahead and CD into the thesis folder. And just to kind of look, right? There should be nothing in there. So shell, exercise, writing, right? Okay, writing, and then thesis folder is empty. So what we're going to do now is create a text file. So we're going to run nano draft.txt. Hopefully that didn't cut out too bad, but I wrote nano draft.txt into the command terminal. Oh, I have no internet right now. Oh no. Okay, we're gonna have. Okay. We should be back now, so I had to lower down the streaming resolution, unfortunately. But nanodraft.txt, right? Okay, so we're gonna hit enter. Oh, oops. I hope I didn't do nothing there. Okay, enter. Okay, now it gives us this little graphical interface inside of the, or almost like a Word document inside of the command shell, which is pretty cool. So when we say nano, nano is a text editor. We really do mean text. It can only work with plain character data, not tables, images, or any other human-friendly data or media. We use it in examples because it is one of the least complex text editors. However, because of this trait, it may not be powerful enough or flexible enough for you for the work you need to do after this workshop. On Unix systems such as Linux, Mac OS, many programmers use Emacs or Vim, both of which require more time to learn. What is that? Vim, ubiquitous text editor. Vim is highly configurable text editor built to make creating and changing any kind of text very efficient. It is included as V, the most Unix system. Okay. Vim is rock stable and is continuously being developed to become even better. What does Vim actually do? Vim is an advanced text editor that seeks to provide the powerful of de facto Unix. Okay, so it's text editor for Unix systems. Gotcha. Okay. Emacs or Vim. Both of which require more time to learn, or graphical editors such as Gedit. On Windows, you may wish to use Notepad++. Windows also has a built-in editor called Notepad that can run from the command line in the same way as Nano for the purpose of this lesson. No matter what editor you use, you will need to know where it searches for and saves files. If you start it from the shell, it will probably use your current working directory as its default location. If you use your computer start menu, it may want to save files to your desktop or documents directory instead. You can change this by navigating to another directory the first time you save as. Let's type in a few lines of text. Once we're happy with our text, we can press Control O, press the Control or Control keyboard or key while holding it down, and press the O key to write our data to disk. So here we go. It says right here, write out, and so it gives you the commands here at the bottom as well for you to use. Okay, sorry. To write our data to disk, we'll be asked what file we want to save this to. Press return to accept this default of draft.txt. Okay, and that's what we named it. So it's not publish or perish anymore. It's share and thrive. And then we'll hit Control O. Hit enter because it tells us right there at the bottom, file name to write is draft.txt. Hit enter. And now we can hit Control X to quit the text editor. Control key is also called control key is also called I call it control key all the time, CTRL, but control key. Oh my goodness. There are various ways in which using control key may be described. For example, you may see an instruction to press the control key while holding it down and press the X key, described as any of Control X, Control X, Control X, Control X. I mean, I just honestly see it as Control X, but the sorry, what is it? The exponent X, but that counts as control, and then CX. In Nano, along the bottom of the screen, you'll see up G, get help, up O, write out. This means that you can use Control G to get help and Control O to save your file. Nano doesn't leave any output on the screen after it exits, but LS shows you that we have created a file called draft.txt. So now, since we're in here, let's go ahead and hit LS, and boom. Now in our thesis folder, we now have a folder called draft.txt. We have seen how to create text files files using the Nano editor. Now try the following command. Touch my file.txt. What did the touch command do? When you look at a current directory using the GUI File Explorer, does a file show up? Use ls-l to inspect the files. How large is my text file? Then, when you want to create a file, when might you want to create a file this way? Okay, so ls-l. Oh. Okay, so touch creates a file. The touch command generates a new file called myfile.txt in your current directory. You can observe the newly generated file by typing ls at the command line prompt. Myfile can also be viewed in your GUI Explorer, which is our file explorer here, right? Thesis, boom. Okay. When you inspect the file with the LSL, note that the size of my file is 0 bytes. In other words, it contains no data. If you open the myfile.txt using the text editor, it is blank. Some programs do not generate output files themselves, but instead require that empty files have already been generated. When the program is run, it searches for an existing file to populate with its output. The touch command allows you to efficiently generate a blank text file to be used by such programs. And so then if we wanted to, we can go nano my file dot text, and see, it opens it up, and then something, right? You can type something in there, aka hello world, and then we can write, and then exit. Let's do cancel. No. So now when we open up nano I forgot we can just use there we go. Open it again, it saved what we had done, and then we can I think I can, yeah, there we go. So let's go ahead and save that, and then exit, and let's run that one more time just to see. Boom. Okay. But what we can do is have that up again. See how much our file size is. Oh, apparently it has an amount now. So let's nano my file text, enter, make sure. Oh, there we go. Okay. Yes. And now we should have 0 data in there. Okay, let's just keep it how it was that they gave us. You may have noticed that all of Nell's files are named something dot something, and in this part of the lesson we always use the extension dot text. This is just a convention. We can call a file my thesis or almost anything else we want. However, most people use two-part names most of the time to help them and their programs tell different kinds of files apart. The second part of such a name is called the file name extension, and indicates what type of file and of data, indicates what type of data that file holds. The .text signals a plain text file. .pdf indicates a PDF document. .cfg is a configuration file full of parameters for some program or other, and .png is an image, and so on. This is just a convention, albeit an important one. Files contain bytes. It's up to us and our programs to interpret those bytes according to the rules of plain text files. PDF documents, configuration files. Is that? Oh, you need batteries for this? Okay. Okay, Daddy, we'll see if he can find some.
Daddy, find them.
Okay.
Daddy, find them.
I know, baby. I'm gonna have to take it apart, okay? You're gonna have to wait. Daddy'll get some. She has a little book, and it takes batteries. Daddy'll get some more. You gotta wait, okay?
Batteries.
Daddy's learning right now, and then Daddy'll put batteries later.
What's that?
I don't know, baby. Who is it?
What's that?
That's Blue. Give me Knuckles.
Pickles.
All right, high five. I love you. Oh, too slow. Too slow. All right. One more time. Good job, baby. Uh-oh, do you have poo-poo? Do you have poo-poo? Okay, Daddy will change you in a second. Alright, sorry. PDF documents, configuration, images, and so on. Okay. This is just a convention, albeit an important one. Files contain bytes. It's up to us and our programs to interpret those bytes according to the rules of plain text files, PDF documents, configuration files, images, and so on. Naming a PNG file of a whale as whale.mp3 doesn't somehow magically turn it into a recording of a whale song, though it might cause the operating system to try to open it with a music player when something double clicks it. Moving files and directories. Returning to the shell lesson. Oh gosh, he stinks like poop. Okay, let's put on some music. I'll be right back.
Again? One more time.
Okay, I'm back. Okay. Huh? Oh, they are? Dang. The big ones or the smaller ones? Because there's different sizes. Oh, okay. 3 of them. Okay. So I'm actually... No, okay. Returning to the shell lesson data exercise writing. So let's go up one directory. In our thesis directory, we have a file. Let's do the way they want us to do it. Let's go ahead and cd back to the main, and let's cd tilde desktop shell exercise writing. Right. Remember, you can use your tab key and push yourself up directories. So, alright, so in our thesis directory we have a draft.txt, which isn't a particularly informative name. So let's change the file's name by using mv, which is short for move. Oops, sorry. Jamming. Okay, which is short for move. So we're gonna do mv thesis. Actually, let's right, let's cd thesis ls, right, let's okay. Alright, so now we're gonna go back into writing. Oh, okay. So now what we're going to do is we're going to use the move command. So we're going to move. What are we moving? I don't know, but we're going to move thesis draft.txt and change it to thesis draft quotes.txt. The first argument tells mv what we're moving, while the second is where it's to go. In this case, we're moving thesis draft.txt to thesis quotes.txt, which has the same effect as renaming the file. Sure enough, ls shows us that thesis now contains one file called quotes.txt. So let's go ahead and hit enter on this command, and let's check our thesis folder. So there we go. Now, instead of it saying well, it was draft.txt before, now we have quotes. The first argument, okay. Okay, now contains one file quotes. Gotcha. Okay, so we did it. Shows us the output of quotes. One must be careful when specifying the target file name, since move will silently overwrite any existing file with the same name, which could lead to data loss. An additional option, mv-i, or move interactive, can be used to make move ask you for confirmation before overwriting. Note that mv also works on directories. Let's move quotes.txt into the working directory. We use mv once again, but this time we'll use just the name of the directory as the second argument to tell move that we want to keep the file name but put the file somewhere new. This is why the command is called move. In this case, the directory name we use is a special directory name, period, that we have mentioned earlier. Okay, so now what we're going to do. Okay, sorry, I'm getting a little distracted here. Okay, so move once again, but this time we'll just use the name of the directory as the second argument to tell move that we want to keep the file name but the file somewhere else new. This is why the command is called move. In this case, the directory name we use is a special directory name, period, that we mentioned earlier. This effect is the effect is to move the file from the directory it was in to the current working directory. ls now shows us that thesis is empty. Okay, so let's go ahead and try that. Move thesis quotes dot. Right? Is that a period in there? Yeah. And then we'll hit that. Oh, sorry, ls thesis. And now ls thesis is empty. Alternatively, we can confirm the file quotes text is no longer present in thesis by explicitly trying to list it. ls thesis quotes. So we can no longer, the autofill doesn't work anymore. And it's going to give us an error that that file no longer exists. Sorry guys. Okay, sorry about that. I really don't want that toy going off. It's distracting me. Okay. Oh, and this is a good time to kind of input on that. Like, coding is not going to be easy. It's not going to be where you're going to have head free space all the time, and you're going to struggle. It's going to be difficult. And I know from experience, I know we're going through all the basic stuff right now and learning how to move within the file directory and all that kind of good stuff. But we need to learn this so that way we can become better at what we do later on. Like I said in the intro, I'm not a professional programmer, but I want to be. So I know that having distractions in the house is doesn't always work in your favor, because you're trying to learn and then you get distracted, you know. But I'm not saying anything bad. I love my daughter, and I'm sure that plenty of you out there have kids too. So I love my child, and I don't want her to ever feel that I don't love her or anything like that, and that I don't care for her if she's having fun or enjoying life. That's all I want for her, honestly. So I'll never treat her bad. Only I'll mute myself like that if just to alleviate the sound for you guys, because it's still going on for me. Don't worry, trust me. But I mean, I don't really care. But as I said in the previous episode, I'm just trying to get everything good for you guys, and I know not everyone likes having distractions in the background. So anyway, I appreciate you guys for sticking through. Let's continue learning the command terminal. Okay, so it'll tell us that no directory exists. As an argument, only lists the requested file or directory. If the file given is an argument doesn't exist, the shell returns an error, as we saw above. We can use this to see quotes.txt is now present in our current directory. So if we go ls quotes, ls okay. So that period that we did, where we go? Right? Where's it at? Okay. So the period the effect is to move the file from the directory it was in to the current working directory. Okay. So that's what that does. It moved it into the current working directory. Okay. I just want to make sure we're okay. So quotes exists inside our writing directory, the current working directory that we are in. After running the following commands, Jamie realizes that she put the files sucrose.dat and maltose.dat into the wrong folder. The files should have been placed in the raw folder. So LSF analyze raw LSF analyze fructose dot dat glucose dot dat maltose dot dat sucrose dot dat CD analyze. Fill in the blanks to move these files to the raw folder. Okay, so sucrose, so move sucrose.dat and maltose.dat to, we're going to move it to analyze raw, right? No. // raw. Recall that .. refers to the parent directory, i.e. one above the current directory, and that .. refers to the current directory. So ... parent directory, which would be analyzed, right? And then well, because those are in analyzed, so we're moving it up and then to raw. Okay. So the ... moves us up the directory. So sucrose.dat, maltose.dat, and then the command or argument to ... raw will put our two data files into the raw folder. Okay. Copying files and directories. The CP commands work very much like move, except it copies a file instead of moving it. We can check that it did the right thing using ls with two passes arguments. Like most Unix commands, ls can be given multiple paths. Okay. At once. We can check what we did. Okay, so what we're going to do, so we're going to CP, we're going to copy quotes.txt, right? And we're going to copy it to thesis, and we're going to call it quotations, if I can type correctly, .text. Okay, and now what we're going to look for is ls quotes .text and thesis quotations.text. And then boom, it tells us that quotes is in our current working directory, and this is in our thesis directory. We can copy a directory and all of its contents by using the recursive option -r, e.g. to back up the directory. So we can also copy a directory and all of its content using the recursive option. So -r is recursive. I should have been writing all these down. -r. Recursive. To back up directory. Yeah, I have some like ideas to make this channel a little bit better. I want to add a camera above so you can kind of see my desk. Because writing notes is key, and I don't want to continually open up a notepad. I like writing things down because I can feel my hand writing something, and then it feels like I'm pushing that, it's like writing it in my brain. It's almost engraving it. Okay, sorry. I was messaging my friend back real quick. Okay. So, recursive is to back up a directory. So, I actually want to see that man-ls, right? And we're going to search for -r, right? Was it Control X? No. Oops. E? No. That was space up. In? Ah. Reverse order. Ah. Okay. So I guess it depends on what we're using the command for. Anyway. Okay, so we're going to do cp-r thesis backup. So ls thesis and thesis backup. So there we go. Thesis questions, thesis backup. So now we have two folders that have the directories, or well, the directories that have the each quotations text file. But let's try that again without that /. So thesis and thesis backup. There we go. Make it a little bit cleaner so they both look the same. Suppose that you create a plain text file in your current directory to contain a list of the, and it's a cp, let me write that down too. Hyphen, or actually not hyphen, cp copy files and cp-r backup folder and file. Okay. Sorry. Suppose that you created a plain text file in your current directory and to contain a list of the statistical tests you will need to do to analyze your data, and named it statistics.txt. After creating and saving this file, you realize you misspelled the file name. Statistics. You want to correct the mistake. Which of the following commands could you use to do so? You'll do move statistics.txt to statistics.txt. Number 2. Yes, this will work to rename the file. Moving and copying. What is the output of the closing ls command in the sequence shown below? So pwd shows us that we're in users Jamie data. We list it, and proteins.data file is inside of data. So we make a directory called recombine inside of the data folder, and we're going to move proteins.dat to recombined, and then we're going to make a copy of recombined proteins.dat to proteins and move up a directory, so move into data instead of being inside of the recombined, and we're going to be proteins -dat. Protein, yeah, this one. So we'll make a copy of that and move it up to Oh, yeah, because it's only going to list the folder, obviously. Okay, sorry. I was reading through it. So everything that we did here, it put all this nice and awesome file stuff in there. See, and it moves us up a directory. So instead of being making a file into recombined, we now put that file in data, and we are right. No, it moves it up to. Wait, okay. Hold on. Let's go look at that one more time. When it talks about the dot. Where is that at? About moving it up a directory and down a directory. Okay. Right. MV. And we want to move it into raw. Dot raw. Okay. So we got PWD, we got that, ls. We have proteins data inside of the data file. Okay. So we make a new directory inside data. Is it inside of data? I would think so. Okay, yeah, we're making a new directory inside of data called recombined. And then we're going to move that proteins.dat to recombine. And then we're going to copy recombined proteins and copy it to there. So as of right now, there's just a folder named dat when we view what's inside of data. But this folder has a file named protein, and then we make a copy of it and put it into the parent directory, which would be Jamie. Okay, so move. So we start. So it would just be recombined. That's all we would see when we list inside of the data file, the data directory. So this is the only thing that we'll see. So we just so we start in the user's Jamie data directory. We create a new folder called recombined. The second line moves the file proteins data to the new folder recombined. The third line makes a copy of the file we just moved. The tricky part here is where the file was copied to. Recall that dot means to go up a level. So we copy the file is now in user's Jamie. Notice that okay, because we're inside of there, and we go up one, which was the user. Okay, was Jamie's file. Not with respect to the location of the file being copied. So the only thing that will show using ls in user's Jamie would be recombine. Okay, now that makes sense. Now that I've gone through that. Okay, we're almost done. We're almost there. Hi, TT. Okay. Sorry, my cat came to come cuddle. Okay. Removing files and directories. Returning to the shell lesson data exercise writing, which is what we're in. Directory. Let's tidy up this directory by removing the quotes.txt file we created. Okay, hold on. Let's did I hope not. I hope not. Okay, come on Tina, hold on baby. Okay, so we have quotes in here now. Returning to the shell, we can use rm to remove. And we'll remove quotes. And just to confirm, boom, it's not in there no more. Or, oh, we're supposed to look for it actually. But I know that it's not there no more. My poor kitty cat. Okay, deleting is forever. The Unix shell doesn't have a trash bin that we can recover deleted files from, though most graphical interfaces to Unix do. Instead, when we delete files, they are unlinked from the file system so that the storage space on the disk can be recycled. Tools for finding and recovering deleted files do exist, but there's no guarantee they'll work in any particular situation, since the computer may recycle the file's disk space right away. Using rm safely. What happens when we execute rm-i thesis backup quotations.txt? Why would we want this protection when using rm? So what it's going to do, from what we read earlier, this -i, and let's actually go look inside of right. We're going to look for -i, and we're going to. There we go. Oh, excuse me, Tina. You can't stay there, please. So, indicator style. I think it's Control-N goes up. Print the number of each file. Do not list implied. Ignore pattern. Goes in. Or was it shift in? It was shift in. Nope. Okay, but what it should do is it should ask us if we are sure. Alright, remove regular file, and it'll ask us a question, and then we give it an answer. The I option will prompt before every removal, using the Y to confirm, deletion, or N to keep the file. The Unix shell doesn't have a trash bin, so all files removed will disappear forever by using the I option. Alright, well, all files removed will disappear forever. By using the -i option, we have the chance to check what we are deleting, that we are deleting only the files that we want to remove. If we try to remove the thesis directory using rm thesis, we get an error message. That's because rm by default only works on files, not directories. Can remove a directory and all its components if we use the recursive option R, and it will only will do so without any confirmation prompts. Given there is no way to retrieve the files using the shell, rmr should be used with great caution. You might consider adding the interactive option. I was trying to see if cursive. Okay. Anyway. Operations with multiple files and directories. Oftentimes, one needs to copy or remove several files at once. This can be done by providing a list of individual file names. So I don't know if it wanted us to do this. But I guess we can try it out just so you all can see. Ow, hit my elbow. So we're going to do rm-i thesis backup quotations.txt. Enter. Remove regular file thesis backup quotation.txt. And we're going to put in. So it doesn't remove it. And then we can try to remove thesis. And it won't because it's a directory. And then there's that. Alright, so. Operations with multiple files and directories. Oftentimes, one needs to copy or remove several files at once. This can be done by providing a list of individual file names or specifying a name pattern using wildcards. For this exercise, you can test the commands in the shell lesson data exercise data directory. So we'll go cd, we'll go up one. So we're going to make a directory called backup, if we can spell. And we're going to cp creatures minotaur.dat creatures unicorn.dat backup. Okay. And then cd creatures and list it. So now we have basilisk, minotaur, and unicorn. Okay, so now we have a backup. Oh, sorry. ls f backup. Okay, anyway. CP Minotaur. Target basilisk.dat is not a directory. Okay. So if given more than one file name followed by a directory name, the destination directory must be the last argument. CP copies the files to the name directory. If given 3 file names, CP throws an error such as the one below because it is expecting your directory name as the last argument. Using wildcards for accessing multiple files at once. So we can back up multiple files, which is pretty cool. So if we actually cd and we ls, right, and let's cd into backup, and let's list everything in here. So we have those. If we cd dot dot and then cd into creatures and lsf, boom. Okay, so we have those. Let's clear data. Let's cd back into exercise data. Okay, using wildcards for accessing multiple files at once. A asterisk is a wildcard which matches 0 or more characters. Let's consider shell lessons data, exercise data, proteins directory. The asterisk.pdb matches ethane.pdb, propane.pdb, and every file that ends with pdb. On the other hand, p asterisk.pdb only matches pentane.pdb and propane.pdb. Because the P at the front only matches file names that begin with the letter P. Question mark is also a wildcard, but it matches exactly one character, so question mark ethane.pdb would match methane.pdb, whereas asterisk ethane.pdb matches ethane.pdb and methane.pdb. Ah. Okay, because it's saying we're missing, but it matches a character that we're looking for. Okay. Wildcards can be used in combination with each other. Question mark, ane.pdb matches 3 characters followed by ane, giving cubane.pdb, ethane.pdb, octane.pdb. When the shell sees a wildcard, it expands the wildcard to create a list of matching file names before running the command that was asked for. As an exception, if a wildcard expresses Alright, if a wildcard expression does not match any file, bash will pass the expression as an argument to the command as it is. For example, typing ls *.pdf in the proteins directory, which contains only files with names ending in pdb, results in an error message that there is no file called *.pdf. However, generally commands like wc and ls lets the list WC and ls see the list of file names matching these expressions, but not the wildcards themselves. It is the shell, not the other programs, that deals with expanding wildcards. So, list file names matching a pattern. Run in the proteins directory. Okay, hold on, baby. Excuse me, Tina. So let's cd into proteins. ls, right? Run the proteins directory, which ls commands will produce this output. ethane.pdb, methane.pdb. So we just learned. Excuse me, Tina. So let's try them out. ls asterisk t asterisk ane.pdb. So ethane, methane, octane, pentane. Okay, so that would work because it's any in between, so whatever letter, but there's definitely a T, right? So ls asterisk T question mark ane, sorry, any dot asterisk. So octane and pentane. So why those two? So it's whatever characters T and then I'm missing a letter. Oh, because those have an H and then it ends any dot and then whatever file name that matches those characteristics. Okay, so that works. ls asterisk T question mark ne dot pdb. So ethane and methane, and why? Because it's any characters, and then there's two letters missing that we have to match, and the other ones just go TANE, and these go THANE. Cool. And then ls ethane dot asterisk just ethane dot pdb, because it's specifically looking for ethane, but we don't know which file type it is. Alright. The solution is 3. Oh, but we're asking for methane and ethane. So 1, 2, 3. So the first one, the second one, and the third one. Wait, first one, second one. Oh, okay. Oh, so only those two. Okay, gotcha. Okay, so it was going to be that one. So all the files whose names contain 0 or more characters asterisk followed by the letter T, then 0 or more characters asterisk followed by the letter, or followed by ane.pdb. This gives ethane.pdb, methane.pdb, octane.pdb, methane.pdb. Shows all files whose names start with 0 or more characters asterisk followed by the letter T, then a single character question mark, then any, followed by 0 or more characters. This will give us octane.pdb and pentane.pdb, but doesn't match anything that ends in thane. Yeah, that's what I was looking at earlier. Okay, fixes the problems of two options by making two characters between T and ane this is a solution because they have TH. And the rest of them go Tane or Bane. And then 4 only starting with ethane. That's it. So Sam has a directory containing calibration data, datasets, and description of the dataset. Before heading off to another field trip, she wants to back up her data and send some datasets to her colleague, Bob. Sam uses the following commands to get the job done. So we're going to copy dataset, backup, so to a backup file of datasets. And then we're going to copy calibration backup. Calibration CP 2015. Send to Bob. Oh, so it's going to copy whichever one that she picked into a folder called Send to Bob, and then make another directory called All November Files. Or unless she has one, there it is, right there. And then CP Send to Bob. And then copy whatever to send to Bob. All that is created on the 23rd. Okay. Hey, that's cool. I was meant to see that. Anniversary date, y'all. For me and my wife first getting together. November 23rd. Help Sam by filling in the blanks. Resulting directory structure should look like this. We're going to copy datasets. Dataset, which is this folder, to back up datasets. Right? And then we're going to copy up. Or actually, what are we in right now? We're in datasets. So we're in dataset, I mean. So we need to go / backup and then / calibration. And then / whatever file or all, and then backup to calibration, right? And then CP 2015, whichever file, specific one in data, send to Bob. That was an accident. Okay. So CP calibrations.text, backup calibration. Ah, so the asterisk. Looked for. Okay. Okay. So it'd be asterisk calibration.text. Backup calibration. And then 2015 11. Oh, so we went from the 23rd. Gotcha. So anything with the 23rd, we send over to send to Bob. And then we're going to copy asterisk -23 or dash dataset, which is going to be whichever one, the asterisk, sent to Bob. So it's going to get all those with the 23rd sent to Bob. Jamie is working on a project and sees that her files aren't very well organized. LSF, analyze fructostat, raw fructostat. The fructostat and the sucrostat files contain output from her data analysis. What commands covered in this lesson does she need to run so that the commands below will produce the output shown? So LSF. So what that needs to do, it needs to show, okay, ls analyze. But if we want to show both, we can do ls -f and then put analyze, or I think it's // analyze and then space // raw, right? Oh. Jamie needs to move her files fructostat and sucrostat to then analyze directory in the shell expand. Oh, okay. Sorry, I didn't read that correctly then. So when we look here, it shows us that we have that and that, right? And then we want to move those two files into those, so into analyze. So then we go, we'll move any file that starts with dat, or that ends with .dat to analyzed. Okay. Gotcha. You're starting a new experiment and would like to duplicate the directory structure from your previous experiment so you can add new data. Oh, and I guess just to kind of go over this, right? It's, so all of this is in one directory, right? And we want to move these two data files into analyze. So and we want this to be able to show this only, and this to be able to show this. And so what we'll do is we'll move all the .dat files to the analyze folder. Okay, you're starting a new experiment and would like to duplicate the directory structure from your previous experiment so you can add new data. Assume that the previous experiment is in a folder called 2016-0518, which contains a data folder that in turn contains folders named raw and process. Yeah, baby? Oh. Oh, man. You're being so cute. You're so pretty. Swiper, no swiping. Swiper, no swiping. Oh, man. Okay. The goal is to copy the folder structure of the 2016-0518 into a folder called 2016-0520 so that your final directory structure looks like this. 0520 includes data, process, and raw. So this folder so assume that Okay. Since the previous experiment is in a folder called 25, okay? So it's data folder that in turn contains folders named raw and process that contain data files. The goal is to copy the folder structure into the folder called so that your final directory structure looks like this. 2016 data process raw.
Oh no! What happened?
I mean, this would work, right? But
What happened?
what do you mean what happened, baby? So the first few sets of command achieve the objective. The first set uses relative paths to create the top level directory before the subdirectories. The third set of commands will give you an error because the default behavior of makedir won't create a subdirectory of a non-existing directory. Gotcha. The third set of, maybe I meant the second. Third set of commands will give you an error because the first two. The first two will work. Okay. Gotcha. Third set, give an error because it doesn't exist. Gotcha. The fourth set of commands achieve this objective. Remember that -p option allowed by a path of one or more directories will cause make directory to create an immediate subdirectory. So -p followed by path Oh my goodness. Hi George. Subdirectories. I can't believe it. It's not real butter.
I can't believe it.
And
I can't believe it.
the final set of commands generates the raw and process directories at the same level as the data directory. Gotcha. Okay. CP old new copies of file, make directory path, creates a new. Look at me, George. Alright, can I do a print screen here? Oh. That's cool. Dang, I don't want to set up my printer right now, but that's pretty cool. Let's cancel that. What I really wanted to do is like take a screenshot. Print screen. Screenshot. Select the region. Delay before capturing. Give me like 5 seconds. It's gonna be in my pictures folder, but in my pictures folder I want to make a new file. Actually, this would be a good idea. Let's call this screenshot. Oh, sorry. Let's name this file key points. Key point 2. So I think there was one before that. Alright, so let's do key point 3 just to save it. Key point 3. Save in our pictures folder. And let's CD and let's see what we have. So let's CD into pictures. Oh, CD. Oh, okay, let's just clear. Sorry about that. So we're gonna CD into pictures, right? And then let's see what we have. So we have a keypoint3.png. Now we're gonna go ahead and make a directory in here and call it Unix shell. I do underscores, but okay, we'll do it like this. Unix shell course. And we're gonna move key point to Unix. Oop.
Before we do it.
Unix.
Before we do it. Before we do it.
Alright, so now when we look,
Before we
and
do
let's
it.
cd into, and let's see what we have in here. Boom. Key point 3 is now in our directory. Pretty cool. And we can always go and double check that by opening our file window here, going to pictures, Unix shell course, and our PNG file is here. Pretty sweet.
And then my part
So I think that is really cool what we're doing right now.
Mommy,
So let's go ahead and CD back, and we're going to go into CD, desktop, shell. Oh my goodness! Exercise data, and I think we're in the writing one. So it's CD writing. Right? Okay. Oh, watch where you step, little girl. Okay. Hey, baby. I know. Okay, Daddy's almost done, okay? Oh, Daddy dropped him. No. Say no, Daddy. Okay. Daddy's almost done and we'll play, okay? We'll play in just a minute. Okay, so anyway, that was pretty cool. We learned how to move and make and copy and move throughout our command shell and actually move around inside of our computer through the command shell. So thank you guys for tuning in. I appreciate it. I hope everyone has an amazing day. And we'll get back to it pretty soon, okay? No worries. I'm going to be trying to do this as much as possible because I really want to get far. So thank you guys for tuning in. And I hope to see you guys in the next stream. Alright, later.